Good morning and welcome to another episode of How Many Tabs Are Open on Mr. Johnson's Computer. He opened up this tab by itself because I just wanted to set up the computer screen like this. There's a lot of tabs hiding back there. We'll just say one. There's one. That's a lie. It's a lie. All right, so what we're looking at today is not what we were looking at yesterday. Yesterday we were looking at triangles, right? Yeah. So just a couple things. Let's review some words, some very important words. Parallel. Remember, parallel lines are two lines that go on forever and never touch. Other important words for today are perpendicular. Remember, that is when two lines intersect at a 90-degree angle. It's a very specific intersection. And then, of course, you just have intersecting lines. And intersecting lines is just anytime two lines cross at like anything but 90 degrees. So actually that's kind of almost a 90 degree. But so anytime that two lines cross but don't have that little 90-degree square. All right, so perpendicular are 90-degree intersections. All right, so we're going to look today. Yesterday we talked about triangles, right? So we talked about acute triangles when you have three acute angles. We talked about right triangles when you have a right angle in your triangle. And we also talked about obtuse triangles, which look like a lounging chair, right? With the little third line. So we also talked about when we have side lengths the same. So if you have three side lengths the same, it's equilateral. If you have two side lengths the same, remember it's isosceles. And then if none of the side lengths are the same, then that is a scalene triangle. All right, we got the same kind of thing going on with quadrilaterals. We're going to have a bunch of different names for quadrilaterals. Remember, quadrilateral, what that basically means is four lines, or really four sides. Lateral movement is a side-to-side movement, so quadrilateral, four sides. Okay, so what we're looking at right here on the left side are not triangles, they're quadrilaterals. All right, so we can use some of our words like parallel to describe what we are looking at. All right, so I notice we are looking at two quadrilaterals. On the left side, we're looking at a rectangle. Remember, a rectangle basically has two sets of parallel lines. If you think about it, these two sides are parallel, and then these two sides are parallel. All right, and then over here, we're looking at a trapezoid. Right? The reason why it's a trapezoid is because basically it's a quadrilateral, but two of those lines, if we make them go on forever, will intersect, right? As you can see, these two lines, these two sides will intersect. These two sides will go on parallel forever. All right, so basically on the left, you're looking at a rectangle. On the right, you're looking at a trapezoid. Okay, I noticed the same, they're both the same because they have four sides. They have four sides and four angles. Your rectangle has four 90-degree angles. Your trapezoid has two acute angles. Remember, smaller than 90 degrees. And then it's got two obtuse angles, which are greater than 90 degrees, right? Okay, so we're looking at, I noticed that we are looking at two quadrilaterals. They are the same because they both have four sides and four angles. 1, 2, 3, 4 sides, 1, 2, 3, 4 sides, 1, 2, 3, 4 angles, 1, 2, 3, 4 angles. So they're the same because they both have four sides and four angles. They are different because on my rectangle, I have two sets of parallel lines, and on my trapezoid, I have one set of parallel lines and one set of intersecting sides. So as you can see, on the rectangle, I'm going to draw it in red. These lines go on forever. without touching, and then these lines go on forever without touching. Sorry about the curviness. On this one, on the trapezoid, those lines, those sides go on forever without touching. However, if we follow these lines, they will cross over right here at this intersection. So they are different because the rectangle has two sets of parallel sides, where the trapezoid only has one set of parallel sides and one set of intersecting sides. All right, and then I wonder if these are the only quadrilaterals we're going to learn about. I wonder if we had a square involved, if that would be the same or different. If I had a square, is that more like a rectangle? Um, what other quadrilaterals are we going to be using this year? Because you learned about a couple last year, right? So, um, oops, you learned about quadrilaterals that look like this as well, right? So, does anyone remember what those were called? And we'll talk about that in the next couple days. So, um, I wonder how many different polygons we're going to learn. I wonder what's the greatest number of sides on the polygons we learned in fifth grade. I wonder, are these related to triangles? I wonder, are we going to use words like acute angles when we talk about quadrilaterals? I wonder if we are going to talk about obese or obtuse angles when we talk about quadrilaterals. All right, so just remember these words are going to come up a lot. Also, we should put in the words acute. That's going to come in a lot. You should put in the words right, because we got to use right a lot, and then also obtuse. All right, so these are words that we're going to use quite frequently: parallel, perpendicular, intersecting, acute, right, and obtuse, equilateral, isosceles, and scalene. And as you can see, we can even use the words like parallel and intersecting to explain what we're looking at with quadrilaterals. All right, so remember, use all four stems to receive full credit. We just went over all four of them in this, so if you are having trouble, just rewind, and I'll see you in video two. Bye.